the last video in the number system video series, and this video is on the topic remainders. Okay, so here this is an important topic because you can be asked many different kinds of questions from this particular topic. Okay, remainders, there are many different ways of solving the remainder questions. So it is always a popular topic among the question paper setters because so many different kinds of questions can be asked from remainders, right? So the first very basic, there are many different theorems that can be used to solve the remainder questions. So the first one, this is known as the remainder theorem. Here what they are telling us is, suppose I have a number a1 plus a2, okay, and it is divided by n. Now this will be useful for me when I want to reduce the question. A bigger number can be split into component numbers and then solve bit by bit. Okay, that is where we can use this. So here what is done is, remainder of a1 plus a2 by n is equal to remainder of, first you find the remainder of a1 by n. Okay, and then you add it to the remainder of a2 by n. That is what I have written here. Remainder of a1 by n plus remainder of a2 by n. First you do that, and then you further find the remainder of that sum by n. Okay, that will be the same as remainder of a1 plus a2 by n. Okay, once more, your first step is to find the remainder of a1 by n, and then you can find the remainder of a2 by n. Add them together, further find the remainder of that sum by n again. Okay, you'll get the final answer. It will be the same as this. Now you can replace this plus with minus. That is what the next statement says. You can replace this plus operator by a minus operator or multiplication operator or division operator. Okay, so all this you can apply, and then right hand side also, this plus symbol can be replaced by minus operator or multiplication operator or division operator, depending on what we have here. Okay, now another one, if we have two numbers a1 and a2 divisible by n, then their sum, difference and product will also be divisible by n. Okay, why? Because if both of them are divisible, then their sum will also be divisible. If a1 is a multiple of n and a2 is a multiple of n, then a1 plus a2 will also be a multiple of n. a1 minus a2 will also be a multiple of n. a1 into a2 will also be a multiple of n, right? So that is what they have mentioned here. Now another one, a is a natural number and p is a prime number. So it will be better if in your mind you can imagine some example. For example, a is say 3 and p is 2. Okay, so what they're telling us is 3 raised to 2 minus 3 will be divisible by 2. You can check that out if it is correct. Okay, so what is the a here? A is a natural number and p is a prime number. So a raised to p minus a will be divisible by p. That is what they are saying. Now another one is, this is called Fermat's theorem. If p is a prime number and n is prime to p, what do you mean by this statement? N is prime to p. That means n and p are co-prime to each other, or they will not have any common factors among them. Okay, n and p. If that is the case, and p has to be a prime number, then if that is the case, then remainder of n raised to p minus 1 by p is equal to 1. Okay, remember this. This is a very useful one. Many questions are asked using this Fermat's theorem. Okay, and then you have another one. A raised to n plus b raised to n is always divisible by a plus b if n is odd. Okay, so let's see how we can apply all this in the question. Refer to this slide when you have to do the problems. Okay, when you're practicing, you can refer to all these rules so that you can decide which one to use to solve which problem. Okay, so the first one we can do it using Fermat's theorem. So 2 raised to 256 is divided by 17. Then what would be the remainder? Right? So here let us make it smaller. 2 raised to 256 is a very big number. What is 256? It is 16 into 6. So I can write it as 2 raised to 256. I can write it as 2 raised to 16 raised to 16. Right? 2 raised to 16 raised to 16. Now, what is the remainder of 2 raised to 16 what is the remainder when you divide 2 raised to 16 by 17? First, we have to find that out. Okay. So your question has now become remainder of 2 raised to 16 raised to 16 divided by 17. Okay. So first we'll take a small, this will be equivalent to remainder of 2 raised to 16 into 2 raised to 16 into 2 raised to 16. How many times? 16 times divided by 17. So it becomes remainder of A, B, C, D divided by N. Right? I'm referring to this particular thing. If you have remainder of A1 into A2 by N, what do we do? It is remainder of A1 by N into remainder of A2 by N divided by N. Okay, so that is what I'm applying here. It is remainder of 2 raised to 16 by 17 into remainder of 2 raised to 16 by 17 into remainder of 2 raised to 16 by 17. How many times? 16 times, because it is raised to 16. So first let us find out what is this remainder of 2 raised to 16 by 17. Immediately you can write it as 1 because it is satisfying all the conditions of the Fermat's theorem. 17 is prime number, 2 is co-prime with 17. Okay, and this is n minus 1, this is 17, this is 17 minus 1. So all the conditions of Fermat's theorem have been satisfied. Therefore, the remainder is 1. Okay, now what is the remainder when, another kind of problem here, we cannot use any of the rules. This is another kind of totally a different kind of problem. So what have they told us? They have given us an expression of factorials raised to some power, and they have asked us what is the remainder when it is divided by 1152. So here I'll give you the answer. That is 4 factorial raised to 3. If you can try it now. 4 factorial raised to 3, if you try to do it, you will find that there is a 1152 there, or this is divisible by 1152. You can try it out. What is 4 factorial raised to 3? Try to divide it by 1152 and then you'll find that it is divisible by 1152. If 4 factorial raised to 3 is divisible by 1152, won't 5 factorial raised to 3 be divisible by 1152? Because there is a 4 factorial in 5 factorial also. So all the numbers or all the terms of the expression after 3 factorial are divisible by 1152. Right? So you can completely forget about these terms, because whichever term you divide with 1152, the remainder will be 0. So now our question has reduced to this: 1 factorial cubed plus 2 factorial cubed plus 3 factorial cubed. Why have we taken away all the others? Because the remainder of them divided by 1152 is 0. Okay, so now we just have to find the remainder of this expression when we divide it by 1152. So when we simplify this, we get it as 225, and when we divide it by 1152, you know the remainder is 225 itself, right? So the answer is 225. I hope you understood this. We are cancelling all the terms from here because this is divisible by 1152, and all the remaining terms are also divisible by 1152. So we can forget about that and just take these 3 terms, add it up and get the remainder by 1152. Okay. The next one, find the remainder when 7 raised to 99 is divided. Okay, sorry about that. Divided by 2400. So do you remember the power cycle? We have learned the power cycle of 7, right? So first of all, we have to find in what form is this power 99. Okay, so 99 is of the form 4n plus 2. When you divide it by 4, I think you get it as, yes, it is 4n plus 3. So your last digit there is 3. 7 raised to 4n plus 3 is 3. It will end in 3. Okay, now, so imagine this. You have a number ending in 3. You're trying to divide it by 2400, right? So 2400 into some number, you're trying to divide it, right? You're trying to divide it. So when you multiply 2400 with something, what do we get? We will get a number ending in 00 only, right? So the remainder will also end in 3. If this number ends in 3 and we are trying to divide it by 2400, the remainder will also end in 3. Please write it down and find it out to get more clarity on this. If you are not able to imagine it in your mind, please put it down in your book and write it. Write it with any number that ends in 3. You try to divide it by 2400 and check it out. The remainder will end in 3. Now the options given to us are 1, 343, 49 and 7. So which one will you choose? Your remainder has to end in 3. Okay. So 343 is the answer. Once more I'll tell you. First thing you have to do is remember the power cycle of 7. 99 is a power which is of the form 4n plus 3. And then 7 raised to 99 ends in 3. Now when it is divided by 2400, we must get a remainder ending in 3. This, if you are not getting a clarity on this statement, please write it down and check it out. Then you'll understand. Okay. So the remainder has to end in 3. And from the options, we know that only one option ends in 3. So it is 343. Okay. Now this one. 10 raised to 3 plus 9 raised to 3 raised to 752 is divided by 12 raised to 3. So here 10 raised to 3 plus 9 raised to 3 is nothing but 1729. So you have to get the remainder of 1728 raised to 752 divided by 1728. So what is the remainder of 1728 divided by 1729 divided by 1728? It is 1, right? Obviously it is 1. So how many times we have to do that? We have to do it 752 times. Okay, again we are doing that remainder theorem. The first statement in that slide, go through it if you are not understanding what is to be done, and you just keep multiplying it. Find the remainder of one term, just multiply it. Okay, so that is 1 raised to 752. So your answer is 1 again. Okay, here again 43 raised to 101 plus 23 raised to 101 is divided by 66. So there was one statement in that first slide, a raised to n plus b raised to n. Okay, it will be divisible by a plus b if n is odd. So let us see if our conditions are satisfied here. Your n is odd, 101, it is odd. For this is a is 43, b is 23, right? A plus b is 66. So will this be divisible by 66? Yes. A raised to n plus b raised to n is divisible by a plus b if n is odd. Okay, so it is divisible by 66, right? Now the next one, what is the remainder when? This is a factorial problem. Okay, you have to do the simplification here. Now 2 into 8 factorial minus 21 into 6 factorial. Let us first simplify this. Okay, so what I have done here is I have written it as 2 into 8 into 7 factorial. 2 into 8 factorial, 2 into 8 into 7 factorial minus 3 into 7 into 6 factorial. What is 7 into 6 factorial? 7 into 6 factorial is 7 factorial. So now you have this, when it is simplified, you get this 2 into 8 into 7 factorial minus 3 into 7 factorial. Okay, so finally you get 13 into 7 factorial when you simplify it. So your numerator, this is your numerator, and this has been reduced to 13 into 7 factorial. I'm sorry, this is your denominator, divisor. This is your divisor. You have reduced the divisor to this much. You have simplified it to 13 into 7 factorial. And it divides this particular expression. Let us try to simplify this one also. So 14 14 into 7 factorial by, okay, this can be simplified. This can also be simplified. 14 into 7 factorial plus 14 into 13 factorial can be simplified as 14 into 7 factorial. I'm sorry. You have to divide this, okay, term by term we have to do it. 14 into 7 factorial plus 14 into 13 factorial. When divided by 13 into 7 factorial, what happens? You have to divide it into two parts. That is, remainder of 14 into 7 factorial by 13 into 7 factorial. 13 into 7 factorial is your denominator. Okay. What we have to do now is remainder of this by 13 into 7 factorial. So I'm going to split it up into two parts. Remember the remainder theorem, we can split it into two parts now. Remainder of 14 into 7 factorial by 13 into 7 factorial and plus remainder of 14 into 13 factorial by 13 into 7 factorial. So this one, take a look at this one, remainder of 14 into 7 factorial by 13 into 7 factorial. Can we cancel it like this, 7 factorial and 7 factorial? No, we cannot. Okay, we are trying to find the remainder. We are not trying to find the quotient or the final answer of this division. What are we trying to find out? We are trying to find out the remainder. So here, what we can do is we can take the common factor outside, 7 factorial. Okay, so understand this. Remainder of, suppose you have a question like this, remainder of ax by bx. What will you do? X into remainder of a by b. What did I do? I took out the common factor. Don't try to cancel it because we are not trying to divide it. We are trying to find the remainder here. So remainder of this will be, take the 7 factorial outside, 7 factorial into remainder of 14 by 13. Okay, and what about this one? Here you can see that the numerator has a 13, denominator also has a 13. So this will be divisible by this. Remainder, since this is also a multiple of 13, here the remainder will become 0. Okay, and what happens to the remainder here? It is 7 factorial because you have a 14 here and a 13 here. 14 by 13, the remainder is 1. So here it is 7 factorial, but here your remainder will be 0. So this is your answer. The remainder will be 7 factorial. Okay. So that's all for remainders. This is the end of number system. Thank you.